So in this video, we're going to continue to do rational functions, but now we're going to work with higher degrees in the numerator and denominator. So for example, here's a rational function, y equals 4 over x squared plus 1. So now you see in the denominator, we have a polynomial of degree 2. No longer just degree 1, but now it's degree 2. So what's that going to do to our graphs? So to do these problems, the big thing you're going to want to identify is the degree of the polynomial in the numerator and denominator. And again, the degree is just the highest power of x. So that's what we're going to be looking for. The highest power of x in the numerator and highest power of x in the denominator. So I basically break it down into 3 steps. Step 1, we're going to look at the numerator, what makes the numerator 0. That's the x-intercepts. Step 2 and step 3. And I'm going to walk you through these. So the main thing now is just get these in your notes. Maybe pause the video and get them in your notes. And here's more on step 3. Basically, we're going to be comparing the degrees of the numerator and denominator. Based on how the degrees compare, we're going to do various things. So again, just get these in your notes, and I'll walk you through them. So back to our example problem here. Y equals 4 over x squared plus 1. Step 1, we're going to look at the numerator. What makes the numerator 0? Are there any x values that'll make the numerator 0? In this case, there is no x value that'll make the numerator 0, so there is no x-intercepts. And that completes step 1. Alright, so on to step 2. We look at the denominator. Are there any x values that make the denominator 0? In this case, there is no x value that'll make the denominator 0, so there is no vertical asymptotes. And then for step 3, we're going to look at the degrees of the numerator and denominator. The degree of the numerator is 0. There is no x term, so the degree of the numerator is 0. The degree of the denominator is 2. So go back to your notes, look at step 3. We're comparing the degrees. Since 0 is less than 2, the horizontal asymptote is at y equals 0. When the numerator degree is less than the denominator degree, the horizontal asymptote is y equals 0. So with those 3 steps complete, we kind of have a construct for how we're going to start this graph. So every time you're tasked to graph, I want you to do these 3 steps first. It's going to give us kind of key points, key characteristics of our graph. From these 3 characteristics, we can build our graph around it. Alright, so let's get a clean sheet of paper here. I'm going to draw my XY axes. So from step 1, we agreed that there was no x-intercepts. The graph is not going to touch the x-axis because there's no x-intercepts. From step 2, we found out there was no horizontal asymptotes either. So I have nothing to draw in for that. And from step 3, the horizontal asymptote was y equals 0, which is the x-axis. So there's nothing really to draw in yet from those steps, but we have a sense of how it's going to act around it. Quick table of values here. When I plug in 0 for x, I get 4 for y, so I can plug in that point. When I plug in 1 for x, I get 2 for y. And for that matter, if I plug in -1 for x, I also get 2. So I can plot those 2 points as well. When I plug in 2 for x and -2 for x, I get 4/5 and 4/5. So there's going to be some symmetry to this graph, right? It's going to be reflective about the y-axis. And one more point, if I plug in 3 and -3, I get 2/5 for y. And remember now, y equals 0 is a horizontal asymptote, so it's going to approach the x-axis but never cross. So filling in my graph, it's going to be symmetrical about the y-axis. It's going to go down, approach the x-axis, but never touch. Same thing on the left side here. Alright, so I'm going to walk you through 2 more examples here. For this next example, we're going to graph y equals 3x squared all over x squared minus 4. Step 1, we're going to look at the numerator. Are there any x values that make the numerator 0? And there is, this time. When x is 0, the numerator is 0. So we have x-intercept at x equals 0. For step 2, we're going to look at the denominator. Are there any values of x that make the denominator 0? And this time, when x is 2 and -2, the denominator is 0. So that means we're going to have vertical asymptotes at x equals 2 and x equals -2. And then finally, step 3, we're going to look at the degrees of the numerator and denominator. The degree of the numerator is 2, and the degree of the denominator is also 2. So if you look at your notes for step 3, when the degrees are equal, the asymptote, the horizontal asymptote, is the coefficients a over c. So in this case, 3 over 1. So that means the horizontal asymptote is through the line y equals 3. Because if you look at the coefficients of the numerator and denominator, it's 3 over 1. So with steps 1, 2, and 3 done, we have a construct for our graph. We're going to be able to draw in these asymptotes, these intercepts, and kind of have a structure for how our graph is going to look. The asymptotes are going to come in handy because our graph is basically going to work around those asymptotes. Alright, so clean sheet of paper here, the graph. I'm going to start off with my axes, XY axes. And first thing you're going to want to add in from step 1 is that x-intercept at 0. So when x is 0, y is 0. That is my x-intercept. After that, we can input our vertical asymptotes. From step 2, our vertical asymptotes were at x equals 2 and x equals -2. So we actually have 2 vertical asymptotes. So 2 vertical lines that the graph will not touch. So we can draw 2 dotted lines going up, one through x equals 2 and one through x equals -2. And then from step 3, we had a horizontal asymptote through y equals 3. So here are some asymptotes shown in my graph. The graph is going to kind of wrap around these and act around these dotted lines. So a quick table of values. to give us some points to plot. I'll go through it pretty quick. You can go back and check some of your own points, some of your own x values. So when you input these inputs and outputs, you get some points to plot. So the graph is going to look something like a upside down parabola in the center here, and then off in the upper left and upper right portions there's going to be these curves as well. And you'll notice with a lot of these graphs there's going to be some symmetry. Symmetry is going to be a definite part of these graphs. So let that be kind of a guide for you, that as we're doing these, there's definitely going to be some symmetry. And use these asymptotes too. We drew them in there for a reason. These asymptotes kind of guide you where these curves go. They're going to approach these asymptotes but never cross. So they're kind of like guide rails, guidelines for you to draw your curves. All right. One last example here. Y equals x squared minus 2x minus 3 all over x plus 4. Step 1, we're looking at the numerator. What makes the numerator 0? And to do this one, we're going to have to do a little bit of factoring. So off on the side of our paper here, we can write x squared minus 2x minus 3 equals 0. Got to still be able to factor. That skill is not going away. Got to be able to do that. So when you factor this guy, you see that when x is 3 and when x is negative 1, the numerator is 0. So that is going to be our x-intercepts. We got x-intercepts at 3 and negative 1. Step 2, we look at the denominator. What value of x makes the denominator 0? And for this problem, that value is negative 4. So when x is negative 4, that is when the denominator is 0. So that's our vertical asymptote. We got a vertical line through x equals negative 4, and that is our only vertical asymptote. Step 3, we look at the degrees of the numerator and denominator. The degree of the numerator is 2. Highest power of x is 2. And the degree of the denominator is 1. So when we compare those degrees, 2 is greater than 1. Our numerator degree is greater than our denominator degree. So when that happens, we have to divide. Our asymptote is going to kind of be a slant asymptote or an oblique asymptote. It's going to kind of be a slanted asymptote line. So to get that line, that equation of that line, we have to divide. So we're going to do long division, x squared minus 2x minus 3 divided by x plus 4. It's a little bit of tedious work here on the side, but we got to do long division. So you got to be able to do this skill. You got to be able to recall back on how to do this. So when we do long division, the quotient that we get is x minus 6. X minus 6. So that is the equation of our slanted asymptote. The line y equals x minus 6, which is kind of a slanted line, right? Slope is 1, y-intercept is minus 6. if you draw in that slanted line, that is the slanted, or also called oblique, asymptote. Alright, so when we draw that in our graph here in a second, it'll make a little bit more sense when you see it. But just as if you were to draw the line y equals x minus 6, same idea. We're going to draw that line, but it's going to be dotted. It's going to be our asymptote. Alright, so blank sheet of paper here to draw a nice big graph. And this one is a little bit unusual. It's going to kind of need a big sheet of paper here. It's going to kind of be spread out a little bit. So after I draw my xy axes, I'm going to start with my x-intercepts. Remember from step 1 that our x-intercepts were at -1 and 3. So we can plot those two x-intercepts. Then from step 2, we can input our vertical asymptote through -4. X equals -4 is going to be our vertical asymptote. And then finally, from step 3, we have a slant asymptote. So basically, you're going to want to draw the line y equals x minus 6. Y-intercept minus 6, slope of 1. So when you draw that in, it's just like what it sounds like. It's a slanted asymptote. Right? So but it's still an asymptote. So the curve is going to approach these asymptotes, kind of wrap right up next to it, but never cross. We're still going to want to plot some points, so we're still going to want a little table of values here. So plugging in some various x points, we'll be able to get some points to graph. And there's no set number of points. Maybe get like 5 or 6. Choose an even number, on either side of the asymptotes. This is enough to kind of give you a sense of how these graphs are going to look. And with these, it just takes practice. After you do enough, you kind of get a sense of, how they look, how they're going to perform. And again, there is symmetry. For this graph, there isn't reflectional symmetry, but this graph has rotational symmetry. 180 degrees rotational symmetry. So this is what the final product looks like. And what I would like you to do also with all of these, let's, first I wanted to show you kind of zoomed out what this graph looks like. It was kind of hard to see from my first graph, but if you were to kind of zoom out and draw this graph from a distance, I just wanted to show you what it looked like, just so you get a better sense of what that rotational symmetry looked like. So it's kind of like this. But again, what you want to do after you've drawn a few of these, let's use a graphing tool. Let's use either Desmos.com or let's use your graphing calculator. Graph these guys with a device and check your work. So here on my iPad, I've drawn the first graph we did together. Y equals 4 over x squared plus 1. So if you drew that on Desmos here, you see what we drew. And I kind of zoomed in to show you that that graph is going to approach the x-axis really closely, but never cross. So kind of reiterating what those asymptotes do. The next graph we did together, we did 3x squared over x squared minus 4. So when I type that into my iPad, we'll see the exact graph that we drew on paper. And also when you do your graphs on Desmos or your calculator, let's draw in the asymptotes too, to really see what the asymptotes are doing. So after you've input your original equation, put in the equations for those asymptotes. So one equation is y, or x equals 2. That was one of our vertical asymptotes. X equals 2. We could also put in x equals negative 2. And we could also put in y equals 3. And on Desmos, I'm also going to change the color. I'm going to change the color to black and dotted for those asymptotes. If you click and hold the circle there, you can change the color and you can also make it dotted. So now those asymptotes are showing up, nice and sharp. They really stand out, and they're really showing us that the graph approaches those asymptotes but never touches, never crosses. Alright, and then the last graph, one more to do on Desmos.com. We got x squared minus 2x minus 3 all over x plus 4. And this one should really show us that slant asymptote really well. So after I graph the original function, I'm going to graph the asymptotes x equals negative 4 and y equals x minus 6. So I'm going to graph the original here. I'm going to graph the two asymptotes, the vertical one and the slant one, and that should make the graph really stand out here, and it's going to look just like the one we did on paper. Alright, so please, use these tools to your advantage. If you want to check the graphs that you drew, if you want to get, confirmation that you're doing it right, use Desmos.com. It's a really powerful tool, and it's a way to play around with it. If you want to play around with denominators, you want to play around with numerators, how it changes the graph, what it does to it, Desmos is a fun little tool to use.